My name is Shri. I'm the Director of Product Management here at Arista Networks. I'm responsible for the cognitive wireless portfolio. Today, Nadeem, my colleague who's joined us remote, and I are going to be talking about some AI ML capabilities on the cloud. So a quick rundown of the topics for this particular session. I'll kickstart with a quick overview of our cognitive AI ML architecture and the core capabilities of the platform. Nadeem will then follow up with a detailed view of our RCA engine with a demo, and we'll then wrap the session with a couple of demos that showcases the power of the data analytics platform. All right, let's get started. So Pramod just talked about our vision of building towards this autonomous self-healing network. And we at Arista believe that we have the right architecture and the foundation to be able to deliver on that vision. So the first block in the foundation is our network data lake. The second is the unified architecture that extends all the way from the network edge to the cloud. And the third is the data. So let me talk about a little bit in detail of each of these. As you all know, data is critical and is often considered as a lifeline for any analytics AI ML platform, and it's no different for us. Today, we collect data from different entities in the network, including clients, access points, switches, both on the campus and data center, and other broader Arista network portfolio. We collect different types of data, including states, events, logs, metrics, packet captures, topology, including application firewall sessions. We have implemented a real-time streaming mechanism where the state changes on the network can be exported live and instantaneously reflected on the cloud. And for those metrics that are not time sensitive, what we've done is the network edge collects the metrics and sends aggregated stats in frequency, in chunks. And that's what we're super smart about how we treat and transport different types of data. And this has allowed us to build a completely optimized transport mechanism from the network edge to the cloud.
You mentioned like state changes that are like instantaneous on the cloud thing. So I mean, when you say state changes, like anything that goes up, down, any kind of incident or any kind of changes, like let's say, I don't know, if I would change a port VLAN or something.
Yes. A client change a role, a client disconnect.
Is there a fixed time that you have specified for that thing?
No, so these state changes, so there are certain state changes that just goes out immediately live to the cloud. There's no.
What's the maximum you'd say like is?
So
could be anything, but just curious, like
the delay.
Yeah, delay.
The delay really depends on the network delay. That's it, because there's no. So from the network standpoint, we process the data immediately whenever our service or the soft in the APs and in the switches, when it detects a network change, the state is immediately
streamed. I normally push that.
Yeah. And so, but there are other metrics, like say, for example, we collect a lot of stats about, say, RSSI and data rate and even application telemetry. And for those, we don't send them immediately. We collect, average them in 30 seconds chunk, and then send over every 5 minutes, for example.
All right, sir, I have a question for you. Sure. All right, so you're talking about state changes. Do you mean that in more of a broad sense, or do you mean in terms of like the super specific state machine? Can you elaborate a little on?
Yeah, sure. So let's take wireless AP, right? So a state change could be a client when it's trying to connect to the network, it'll try to associate, right? Once it associates, it might try to authenticate. When it's tried to authenticate, it might fail, it might succeed. All these are state changes that are captured in the system, right? Another example is, say, a client is operating, and for whatever reason, the Radius server sends a COA with disconnect. That's a state change for the client on the AP. Or if it changes VLAN because of a change from Radius server, that's a state change. So these are the state changes that we're talking about that gets reflected immediately on the cloud.
So why specify state change instead of, say, event driven?
It could be. I mean, so events could be events is a much more broader in the sense that it could be events too. Yeah, I mean, it's just using different terms, but that's exactly what we mean.
Okay.
Yeah, the answers. Yeah.
Thank you.
So let me ask a question.
Question, Shri.
Yeah, sure. Please go ahead.
is there anything within this framework as shown that detects your own code bugs and alerts the customers?
Code bugs, yeah. So, for example, whenever there is say a kernel crash, we do upload the logs. The events do go to the cloud, and whenever there's a process crash, all those are reflected, in the cloud. And some of this, of course, goes into the backend. That may not be exposed to the customers. It might be exposed to our engineering and TAC. But yes, we do.
Yeah, I just want to point out that there's also a feature in Cloud Vision that also checks for any vulnerabilities that might exist in the existing deployment that have been found in, a variant of that.
So CVP can be a challenge to deal with at times. When you start throwing all of this additional data at it, what's the scaling story there? And am I going to need, how much bigger of a box am I going to need? How's that going to work? Because
so the way we have designed on the cloud is based on pure cloud principles, right? It runs on Kubernetes. It is designed to infinitely scale. I'm sorry.
Then let me clarify. Can you run this on CVP on-prem?
Yes, you could run on-prem. Yes. So all the capabilities. So today, to run CVP, you would need a 3-node cluster, and I think there's a certain requirements in terms of RAM and memories.
So if you want to run Cloud Vision on-prem, basically it's a 3-node cluster is what we recommend, because fundamentally there's a zookeeper that runs among them to choose the active one and then provide redundancy. It's active configuration. Now, in terms of any bandwidth requirement to go from an on-prem, whether it's a switch or an AP to the cloud, we do actually compress a lot of this data when we send to the cloud. So on an average, it's of the order of low 100 kilobits per second per device. Is really what we have seen most of the time.
No, it wasn't the bandwidth I was concerned about. It's the cognitive load on the CVP server for those of us running it on-prem.
Yes. So the on-prem typically, like I said, you can run it as VM or you can actually run it on physical servers. The typical requirement for CVP on-prem is single socket or dual socket, doesn't matter, about 16 gig of RAM. That's the garden variety CVP instances that we put in. We ask for 3. It can run functionally as 1, but we don't recommend that at all. For production deployment, we ask that 3 of these be deployed. So we have the active chosen.
All right. Okay.
I've got a quick question, if that's okay.
Yes, Pete. Sure.
Just looking at your diagram there, you've got your real-time streaming data going to a small thin white box that's unlabeled. Is that like a Kafka bus? Something like that? Or?
Thanks, Peter. I think that was just a virtual representation of where we ingest all this data in the cloud. This is a microservice that can scale up and down, but it's just a virtual a box in the diagram. But behind, it's a microservice that can scale up and down depending on the number of connections that's coming in.
Okay, and obviously I know you've got on the slide there, it talks about data warehouse, but I've also heard you or mentioned today a data lake.
Yep.
Correct me if I'm wrong, I always think of the difference as being a data lake stores sort of unstructured data, and a data warehouse is going to be more structured data. Is that right? And which are you using?
Yeah. So Peter, let me.
Again, I can quickly answer that question. So there's a specific reason why we are calling it data lake, because fundamentally the streaming telemetry that are coming out of these devices actually go into a HDFS file system. On top of it, there's a HBase system that is overlaid, and that exposes a bunch of APIs, much the same way that you would see in normal application data processing, where you would apply a lot of the big data principles and other capabilities, right? So it's deliberate, not just sort of as a marketing term, but there is actually work that we are doing to make sure that there is a notion of a data lake. And the whole thing is, as we talk more about, you'll keep hearing the openness, because it's for our own convenience and also for the convenience of people who want to build at any stage within our processing pipeline. So if you really want to tap and not use our CVP turbine APIs, but instead you want to just talk to those HBase and make some of those low-level calls and build something on top of it, we don't want to shut down that option. We ourselves use it. We might as well expose it to others too.
What's the driving, I guess, what's your best business case for doing things, in particular, this architecture instead of something, I mean, any of the billion other ways you could have done it?
So again, I'll answer and then
sure,
I'll give it to.
yeah.
So the reason why we embarked on this model is partly biased by what happens in a typical web stack world, right? So the whole idea is collect all the state information. There was some earlier discussion around state versus event. We do actually collect both event and state. What I mean by state is, as my agents as in software processes, as they are processing these different items, as they are going through different state changes, there are some state changes that are important for us to know. So we actually take that and put it in the data lake. So the whole idea is collect all this data lake. And of course, we are very sensitive to the data that we collect. We don't collect any application level information or any of those, anything beyond the network headers. And even a lot of these network headers are anonymized at that point. So there's it's not sort of one of those intrusive ways of just pull everything out. So the idea is to collect all. Yes, please.
Well, you said data lake, L-A-K-E?
Yes.
Okay. I was hearing data link. Please
absolutely.
proceed. Sorry.
Right. So the idea is to get all this information, and over a period of time, we run a lot of, ML software, pattern matching software. We just start figuring out through this data and figure out over a period of time what are the even more insights that we can get. And just to give you one quick example, one of them was basically, if you give a MAC address, the system can quickly go and track and say, oh, this MAC address belongs to that container or that VM, and this is what happened in the life cycle of this MAC. It came up on this, it went to that server, it moved here, and this is what happened, and so on. We can give the full life time series, life history of what happened to that MAC. A lot of these kind of insights that we start pulling, and a lot of this, some of the features that you're going to see down the line are pulled out of taking this information. Initially, we don't know what we can do with it, but when we have enough data, look at the data, look at the pattern, compare it with what else you are collecting, and see if something can be created out of that. And it's sort of our own way of realizing more. At the same time, potentially leave it open for others who have vivid imagination to build something on top of it. So it's kind of that combination is what we had in mind when we built this data lake.
I really appreciate you admitting that some of the use cases will develop.
Yes,
That's
absolutely.
good to hear.
Absolutely.
So in the next couple of slides, what I've attempted to do is I've attempted to consolidate all the AI capabilities and technologies that we have presented in this forum the last couple of years. Just to refresh as a refresher for all of you here, and also to provide context for the wider audience. So the first step towards realizing our vision of a self-driving network is to be able to observe what's happening on the network and understand the end-to-end user experience. The first thing the client wants to do when it wants to connect to the network is to be able to get onto the network successfully and to be able to transmit data packets. So here we capture the state changes of the client as it goes through the entire journey of connectivity, starting from association, authentication, getting IP address, resolving DNS, and eventually being able to connect to the application itself. And if there are issues in any of these states, we capture them and highlight them in the dashboard. The second is once the client is connected successfully, we then very rigorously track the key RF KPIs of the clients, including retry rate, RSSI, data rate, and we highlight when the clients have poor RF performance. Where we really want to get to, ideally, is to be able to measure the experience of real applications for these clients, right? So when you look at applications, collaboration applications like Zoom, Hangouts, Teams, WebEx, etc., it's really hard to measure whether the user is having a good experience or not just by looking at the data packets. And this is one area or one of our application of the AI ML model that we built. So what happens here is the AP has the DPI engine. It detects the flows. It detects an application flow. Once it detects a flow, it collects or extracts key metrics or key parameters like bit rate, packet rate, jitter, latency for that flow over a 30-second period, and then sends that 30-second chunk to the cloud. On the cloud, we run this data that we collected through our trained ML model, and the output of that model is marking that chunk, that flow as either good or bad, right? So this is based on the vast amount of data that we collected for every application, through which we are able to, with fair degree of confidence, mark whether a particular flow is good or bad. And we use that information now to highlight on the dashboard to say, what percentage of time did the client have good experience with Zoom, Hangout, etc. So again, this is one good example of how we use ML to accurately detect whether an application is good or bad. Sorry, go ahead.
So when you say, machine learning, is it kind of the just linear regression that everyone's throwing around these days, or is it deep learning? Is it some sort of generated network that is trained on data that you are feeding it as what is good Wi-Fi and what is bad Wi-Fi?
Yes. So what we've done is over a period of time, we collected Zoom traffic for each of these applications. We've collected the flows, we fed the flows into the engine, and when we fed the flows into the engine, we mark them as good or bad, and that goes into training the model. And we've done that for all 7 or 8 collaboration applications. And we continue to improve on that as we get new data, but that is the trained model on which we run the information we collect on the AP about the client.
So here we're kind of looking at two kinds of things, right? One are all of these collaboration applications where in the past, typically people have looked at delays and jitters to figure out if a voice call is good or not, and creating a MOS score of it or all that. But that doesn't really reflect the experience that the person using the application is having. So that we thought it was fit to actually create a trained model. So we've done a lot of supervisory learning, as Shriram mentioned, where we collected a lot of flows. We marked them as this was a good flow, this was a bad flow. That was actually passed through a sort of the kind of machine learning model, which actually created a model, right? And now we can actually match newer flows against the trained model that we have. And we continue to evolve this model as we collect more and more information. That is one level. The other thing is that when you look at flows which are not collaboration application, voice and video, but just TCP flows, there we have a different, the lines start getting blurred between AI ML and statistical analysis, right? Really, because people tend to push everything towards AI ML. But there we can actually figure out how much delay each frame is having, what is the response time. We have actually gathered like 6 or 7 elements that we check for every flow, and we know if that TCP flow will end up in a good experience or not. So if it's, let us say, if it's just like let's say somebody browsing web or somebody using, for example, Salesforce, right? And your connection to Salesforce, is that good or bad? That depends upon a lot of factors that we keep checking on the network, and we keep doing statistical analysis on that flow to tell you how much time of that duration of that particular session the experience was good or bad. So really there is a difference between these two, like collaboration applications where somebody's doing things in real time, and that is done using a supervised learning model. And then there is statistical analysis that we do on flows, which are just general TCP flows, where we can figure out what kind of window sizes are happening, how the data rate is going up and down, what kind of delays are happening on the flows, etc. And we have a model there which can tell you if that experience is good or bad.
So what novel steps is your AI capable of taking without your prompting? I understand like machine learning, right? So for me, the line between machine learning and AI is a really clear demarcation. Mm-hmm. I want an AI to be able to do something I didn't tell it to do, as opposed to machine learning, which is kind of, you expect where it's going. Yeah. So
okay. You want to
Yeah. So I think it's a good segue into some of our next topics.
Sure.
So in the later slides, we'll talk about some of the root cause analysis engine, which actually uses AI, which goes back to, hey, you know what? Yes, the users are having bad experience, the users having a poor connectivity, but what is the root cause of this, right? And then there we use a lot of correlation techniques, and then once we identify the root cause, the next step we want to do is recommend fixes, right? So we'll talk about how we use some of the AI models to provide root cause recommendations and root cause analysis and recommendation. So if you just could hang on for a few slides, we'll come to that, and probably it'll become more clear in the demo that we show.
So the user experience or the quality of experience is very subjective and can vary with a lot of different user cases. So if I have a business and I have a salesperson versus an administrative person, I might want to use the same app but have a different expectation of what is acceptable or not. And it concerns me, the good, bad kind of thing. And so my question is, how adaptable is this for me to then change that for my specific business requirements? Can I have the same app with different measurements?
Great question. So today it's a single model, which means there's a bunch of parameters that go, and based on the trained model, we tell you whether it's good or bad, right? And there's a lot of thresholds that we use in the back end, but the model is built such a way that in the future we can easily expand to capture some of these use cases, right? The definition of good and bad, can be trained in the system in the backend, depending on, like you said, the expectations from different types of users, and that's something that we can feed into the model. Today, do we do? Not yet, but it's what we built is a very, very open model, and we do a lot of what you don't see in the product. We still do a lot of R&D in the back end. We have a data science team that constantly monitors this, plays around with the model, and something that we can definitely look at.
And the definition of good and bad is your definition, not the
right. Today, it's our definition based on the flows that we collected, which were marked as good and bad, which went into the model to train. Okay.
Sriram, just one comment here is that while what Sriram said is accurate here, that today it's a single model, but you will see examples that Sriram will show later where we, as a principle, we don't think we should just have one threshold for everything, and you will see some of the baselines and how we create it in some of the next slides. So that will probably answer you.
Thank you.
Okay. All right. So let's keep going. So the next thing, once you collect all these metrics, the next thing is to identify, if there is an issue in the network, right? We talked about how we qualify or quantify whether an application flow is good or bad. So what about other metrics? For other metrics, we use this technique called dynamic baselining and deviation from baseline to call out issues. So what's unique here, and why is this important, right? So let's take a simple example, a metric like retry rate. One of the most common questions that our customers ask us, our wireless admins ask us is, what should be the threshold for retry rate? And I think the answer is it depends on the environment. The retry rate threshold for carpeted space as compared to a harsh RF environment like say a manufacturing plant or a sorting center could be very different. So what we do is, and all the environment aspect of that metric is captured in the baseline. So what we do is we take the metric, all these metrics, we baseline that metric for that environment, and any deviation is in the context of that environment, right? So when it deviates from the baseline, we say that there's an issue. And another example is, say, AAA latency, right? Say you're in the headquarters in the campus, the AAA server is deployed right in the network within the campus, and say you have a remote site that's authenticating against the AAA server deployed in the HQ. The latency are going to look very different, right? It's hard to define a single threshold. So, sorry.
So one problem that I've always had with this approach is it assumes that your environment is starting from a good place. If you drop a tool like this into an environment that has bad RF performance or bad AAA performance, it'll never tell you, because it's like, oh, well, you never deviated from the baseline, but you didn't tell me that the baseline was bad to begin with. Other platforms have solved that problem by also benchmarking your metrics against, anonymous crowdsourced peers. What is your solution? Tell me if my metric is bad to start with, but consistently bad. So maybe that's good. I don't know.
So great question. So we do two things. One is we definitely do, when we define these thresholds, we definitely do anonymized comparisons of other similar environments, because later on in the presentation we'll talk about how we can gather data across customers in an anonymized fashion, and we'll show a demo of that. But that is one input. The second is we also have guardrails to protect from bad experience. Say, for example, like you said, you start from a clean slate, and the clean slate was not a good state; it was already bad. But we have thresholds that we can define, like which we call guardrails. And if it exceeds that threshold, no matter what, we are going to call out poor performance, right? So there are two models, two techniques how we get around it. All right, okay. So once we identify the issue, the next step is to understand the root cause and provide recommendations. Nadeem is going to talk about this in detail in the later slides. And finally, so over the last couple of years, we've constantly been increasing the number of use cases we support, in our AIML engine, right? Both on the RC and recommendation engine. But there have been cases where our customers have come back with corner scenarios where those scenarios have escaped our AIML engine, right? And in those scenarios, we want to ensure that we provide the right set of tools for our customers to be able to troubleshoot, get to the root cause, and fix those issues. And a core part of that is our multifunction radio. I know a lot of you probably are already aware of our multifunction radio, but this is one of our core differentiators. Essentially, the multifunction radio is a dedicated radio that is part of all our mid-tier and enterprise access points. And the sole job of this multifunction radio is to scan the environment 24/7, collect all the information, and feed it into RRM and WIPs. That's one part. Because we don't depend on background scanning, the dedicated radio is doing 24/7 scanning. We feel that we can react to RF changes much more quicker than if you did background scanning. Number one. Second is this also improves our WIP's efficacy, and Jatin is going to talk about that later. The second function of the multifunction radio is in troubleshooting. So you could actually configure the multifunction radio as a client and make it run tests, like connecting to a network, going through all the authentication, DHCP, DNS, and and trying to get to a specific application. So we have a lot of customers that have used this tool to proactively ensure that the network is up and running before users even complain. A good example of this is in retail environment, right? Before the customers walk into the store, we have customers that have configured the multifunction radio to test the POS server to ensure that, hey, everything on the network is okay from the store to the POS application. So just one example.
Is what you're showing so far everything? Is it just in the solution, or are we looking at different licenses and different? You got to buy this to get that sort of approach.
Great question. All that you see is part of a single license. One single license. You buy the access point, you buy the cloud subscription. There's no tiers, there's no foundation, advanced, enterprise. Everything is part of, everything that you see here is part of a single license today.
So just two SKUs, really. I'm buying a SKU for an AP and SKU for...
Buying an AP, you're buying the cloud subscription. In fact, we make it easier. We actually have a bundle SKU, right? So you buy a bundle SKU that says, okay, 3-year AP 360, 5-year AP 360. So we make it easy for you to consume this product.
And the third radio that you mentioned, like the testing and all that, when we configure it, is that something like a manual thing that you have to kind of run, or once I configure it, I can make it, hey, just run it every 30 minutes?
Yeah, schedule it. Yeah, so that's what a lot of our customers do. They, like I said, the retail example, they actually configure to run at 5:30 a.m. in the morning before the store opens at 6. It runs its tests, sends a report to the admin, or alerts if it found any issue in that connectivity test. Yeah.
So single panes of glass are awesome if you're single vendor, but I don't know very many people who are. What mechanisms do you offer to get the telemetry going into CVP, out of CVP, and into your own Kafka message bus if you have one running, plugged into Grafana, all that good stuff, right? How I know how to do it. I know how to do it with switching products from your company, but can you do it with? Can I get also that similar data from the cloud CVP into my message bus for these events, letting me know when things happen, so that my operations team can see it in their single pane of glass?
Yeah, sure. So, Kumar mentioned earlier, we've been very open. With our, everything that we do is very open. So every data that you see in NetDL, right, can be exported by any third-party application. So everything that you see on a dashboard can be exported, can be queried by any third-party application sitting on top.
Okay, but is there a push mechanism like webhooks or some sort of thing so that I'm not polling constantly and probably getting rate limited by your API?
Yeah. So for specific applications like locationing, right? We do have a streaming mechanism from the AP to the locationing server. Are there any other applications?
Actually, I'll answer this. Yeah. So any data that goes into the NetDL, you can access it over secure gRPC, WebSock, and a subset of it over REST API.
Okay, that makes me happy.
So I actually have a question from socials for you guys. How do you deal with outliers like high density, say events that come and go with the network left as it is? So if you're not changing infrastructure, how do you handle those outlier events?
Could you clarify a little bit more? So could you clarify that question a little bit more?
Sure. So Arista, say I have a regular office network, right, with you guys. If I have 300 employees come in on, say, a room covered with 3 directional APs, how do you guys compensate for spikes like that in terms of monitoring? Do you have any features that would facilitate a big change like that?
Yeah. So I think the going back 2 slides, the baselining, right? I'll show it in the demo, and it'll show up really, like we have a specific use case for that. The baseline, once you start looking at the baseline, the chart will clearly show what's happening with the metric. So it could be, if you have a lot of clients coming in, what's the impact that it's having on the RF environment, in terms of channel utilization, in terms of data rate. Are the clients getting the right data rate? Is the retry rate within the limit? All that is going to be captured in the baseline, and I'll talk about that when we show the demo, because it become much more clearer on how we deal with it. If that's yeah.
Thank you.
Okay.
Hey, Sri, if I can just add one quick point.
Sure. Yeah. Please. Go ahead.
The earlier question about being able to do multi-vendor management and take data out of NetDL. Just an example, we have a large Bay Area company that's actually deploying Wi-Fi 6 EAPs right now, and exactly that use case where they're taking all the telemetry not from our system, but they wanted it directly out of NetDL so that they can process it themselves and do things that they wanted to do. So yeah, that's absolutely a use case we support.
Yeah. And Pramod, just to add on to that, I mean, in fact, they've gone further step where they use open config to configure directly on the access points. So yeah, okay, right. So
one more example that I really want to point out here is one of the largest service providers in India uses our Wi-Fi for Wi-Fi offload from their 4G network, and they are using our NetDL to extract all the telemetry from the Wi-Fi. They have telemetry coming in from their 3GPP environment as well, and they're sort of merging all of this together to figure out their SLAs to their end customers and everything else. So they're one of the larger sort of people who have got almost 250,000 APs all across India, and they are sort of picking up telemetry from our NetDL and using that with the 3GPP environment to give consolidated metrics.
So a big problem with specifically, RAN offload is conceptualizing. Let me restate that. A big problem with the offload is getting the hard data as to how effective that is one way or the other. Do you have a solution for that?
So we don't actually have a solution, but during the breakout, I'm happy to walk over the solution that this service provider has done in India to figure out, because, and I'm sure it's the same thing in the US, but the Indian government poses very hard limits on what kind of SLAs, the service provider need to promise when people are paying money for those services. And what we do, I'm happy to kind of talk you through the specifics of that.
Thank you. Look forward to it.
Awesome. All right. So, so the last thing I want to just leave here is, like I said, we collect a lot of logs, live and historical. One of the cool features we have is live debugging, where we track the client, send live logs about the client to the cloud, so that you can almost instantaneously troubleshoot and look at what's happening on the network. The second thing is I also want to leave is with is when we send a lot of these events, especially failure events, we enrich that event with additional information like packet capture logs, so that admins can go back in history, look at what's happened, and that'll help them troubleshoot the issues faster, right? So
the packet capture is basically, I mean, it's event driven, right? Like if there's DHCP failure, it'll tell you, hey, this is a PCAP, it was a DHCP failure, and it will have all those frames in there and that kind of stuff.
Yeah.
And then under live and historical client debugging, for example, roaming, right? I mean, will it show the historical data of the roaming, for example?
Yes, and also live. So for example, say you're troubleshooting a client.
So I can tell him to walk around and I can see it live. Where
absolutely, yeah. And you don't even have to say which APIs you want to pick the logs from, right? You just say, I want to follow this client, send me live logs. That information command goes to all the APs in that environment, and whichever AP sees the client sends the logs back. So you'll see a constant stream, and that goes for the packet capture too, right? So we ensure that we automatically I mean, even when the client roams, we capture all of that. And on the just to quickly mention on the auto packet capture, what we do is we kind of completely strip the data packets, just for privacy purpose, because all that we need is the IP headers, right? So we strip the IP headers, clear out the data packet, data payload, and send only the IP header to the cloud.
So one more on this, sorry. So this is on the wireless side. So if somebody has a full Arista solution, for example, so I have clients, for example, they're hardwired. Is it something similar? You'll have PCAPs for them too?
Yes, actually, that's a good point, because, and we'll touch a little bit more when we talk about the overall network design. So one of the key things that we embedded in the campus wired access switch is a feature called flow tracker, right? What it does is, in the hardware, in the switching hardware, there are actually two hardware pipelines. One pipeline is purely in the packet forwarding path. ACL lookup, IP lookup, send it out. There is another pipeline which works on the copy of the packet, whose sole job is to generate per packet telemetry. And these telemetry is not the traditional model where you first send it to CPU that needs to do the heavy lifting of formatting and everything. It actually happens in the switch chip itself. The per packet telemetry is actually sent out as IPFix v10 streams. And that makes it, much more easy to consume, because there's no CPU involved. There's nothing like, oh, I have weak CPU. I can only process 1/10 of your data or 1/100th of your data, and so on. All those issues goes away. This is literally per packet telemetry, where it actually updates this telemetry. It actually gives you the runtime average, basic histograms of the data as it collects, and you get everything as a IPFix v10 stream at that point in time.
So as we mentioned in the earlier part of the presentation, we have a root cause analysis and recommendation engine. The next few minutes, I'm going to talk about how this works, and also show a demo of this in action. So starting off with what do we do? So basically, the root cause engine looks for symptoms of poor performance. So symptom could be low data rates. So symptom could be, say, poor application performance. So whenever such a symptom is detected for one client or a group of clients, then the root cause engine looks at multiple pieces of information which is available to us, courtesy the data lake that Sriram talked about. So we look at the system knowledge, which essentially what is the configuration applied to the APs at this location in terms of what knobs are enabled, what features are on, what features are off. So the entire configuration at AP level, radio level, society level, everything is taken into account. We're also looking at the clients themselves. So in terms of what are the currently connected clients, what are their capabilities, what are their RF KPIs, what are their application performance indicators. And then finally, we have what we call as domain knowledge, which is actually our view of how different Wi-Fi parameters relate to each other. And this is where, when we look at performance across customers, we are able to, get more insights into how the system behaves with a given stimulus, so we can correlate, what would cause a particular symptom. So by taking into account these three things, that is the observations, the domain knowledge, and the system knowledge, the RC engine is able to figure out what is the root cause or what is the set of root causes for a particular symptom, and then also provide recommendations to the admin in terms of what can be done to solve this problem. And finally, also evidence in the form of graphs and charts, which can help the admin understand what's going on, why things went wrong, and how the recommended change can help get things better. So that's the overall framework that we are implementing. And to give a little bit more detail, let us look at one example of how the root cause analysis engine might run. So if you take low data rate as a symptom, so now this could be caused by various reasons. The simplest reason could be that the client which is exhibiting this symptom, maybe a legacy client may not support the latest, protocol. For example, it may not support 11ax in 2.4 or 5. So that could be a simplest cause, but then also be reasons like, maybe a single band client not able to take advantage of 5 gigahertz, or a dual band client not able to take advantage of 6 gigahertz. There could be a misconfiguration on the client side. For example, even though it's dual band, it is connected to 2.4 band only. So maybe that's a setting issue on the client, or there could be a misconfiguration on the network side where, even though the radio is capable of 5 gigahertz, but the strike is not enabled on all the radios that access point is supporting. So these could be simple reasons, but then if you look at more complex aspects in terms of the RF environment itself, this low data rate can be caused by, for example, high retries. Now, high retry itself is not a symptom, but this is, you can say a reason why this low data rate happened. And the retry rate may be high either because the SNR is that the client is seeing is low, which in itself could be because the SSI of the client is low, just leading to low SNR, or there is a lot of noise which can cause the signal to noise ratio to go down. Or the other hand, it could also be caused by higher contention. So, for example, there is high channel utilization, or there are too many clients which are hogging the channel. So we essentially look at all these different possibilities which could cause this low data rate. So in that sense, we go up a decision tree. So you can call it a reverse decision tree, where we start from the symptom and then work our way upwards to pinpoint what could be the reason for this type of behavior exhibited by a client or a group of clients, what we call as single client RCA or a multi-client RCA. So having determined this, the reason or the root cause, the system is also able to, explain to the customer what could be done to change the, situation. For example, if it's a client issue, we can recommend, or provide information about what is the current configuration and how things can get better if you have a different type of client. Or there could be a issue like if the client is not roaming to the right band, then maybe the band steering is not enabled, right? Or if there's the channel itself is facing high contention, then we look at the present configuration and try to see whether the auto channel is enabled or the dynamic channel is enabled or not. So we are looking at the live configuration and not just giving some generic recommendations. So that way we can give very pinpointed reasons as to why this issue is happening. Sometimes it's beyond the control of the Wi-Fi network itself. For example, there could be high non-Wi-Fi interference. In that case, we can recommend to run the spectrum analysis tool in our system so that we can figure out whether the interference is coming from Wi-Fi devices or there are non-Wi-Fi devices in the vicinity which are causing these issues.
Did you? There are, sorry. Did you say run the spec an? So we have to manually run it, or will it automatically run it and report something back?
Good question. So today it is manually run. So we recommend that leverage our multifunction radio to run the spectral scan. So it's not automated.
Okay, gotcha. All right, that's
Okay. So this is how the overall framework works. And I think the innovation here is that you keep looking at your newer symptoms, because we are, adding more KPIs to the network. For example, application experience, which Ram talked about, while we're able to observe, the application is performing well or not, we're also able to feed this information back to the RC engine, which can tell us whether this issue is due to wireless side aspects or the wired side. And if it is due to wireless, then we can go back to the decision tree and figure out, which of these root causes apply in this particular case. So that way we can add more symptoms. We can look at more data which is coming from the network and try to figure out, can we do a more accurate job of telling the customer, why this particular symptom is appearing and what we can do to fix the issue.
On the poor app experience, it says due to wireless right there, right? So what if it's not due to wireless? Will it mark the, I guess, your KOE and all that as, oh, hey, everything is fine, or will it actually still show me something or correlation or something that will tell me, hey, it's beyond Wi-Fi?
So today we sort of give a binary answer. So we can say, is it due to wire side of the network or the wireless side? Okay. As we go into more integration with the wired side of the Arista portfolio, we are looking at, can we answer that question, better in the sense, it's a wired problem. Is it due to a problem with the internet link speed? Is it a problem due to, buffer occupancy on the internet links and so on? But we are not there yet, but we are working towards that. Okay. So I would have loved to do a video demo, but due to a lot of logistic issues, I'm sitting in Bombay, the lab is in Bangalore, the person who runs the lab is in Chennai. So what we decided is in order to, be more productive in the time we have. So we did a recording of the demo earlier. So what I will show you is walk you through the sequence of steps which takes place and how we are able to figure out what happened and how we can fix this. So here we are looking at a access point or a location where we are showing that on the configuration we have enabled the auto channel selection, but here it's a schedule SDS. But we see that the dynamic channel selection now is turned off in this particular configuration. Now, if we go back to the monitoring screen, we can see a list of clients which are connected to various APs. We are particularly interested in these two clients which are connected to the AP that we are interested in. We can see the APs running on channel 104, and these are the two clients. Now, let's go look at the clients as to what is their RF KPIs and what's going on for each client. So here we can see that our RC engine tells us that this particular client is facing very high retry rate, which is possibly due to high contention or low SNR, which is causing performance issues at the client. So if we run the RC engine, which tells us, what is the root cause. So here we can see that the recommendation is to enable the dynamic channel selection. So remember that the automatic channel selection is periodic in nature, so it will run at its designated time. But here the problem could be solved by enabling the dynamic channel selection. That's the recommendation from the RC engine. Now, just to make the update here, we'll go look at the second client also to see, is it having a similar symptom and a similar recommendation. So the symptom is same, and the recommendation from the system is exactly same. That is to turn on the dynamic channel selection at this particular location where the problem is being experienced. So let us go back to the configuration screen and enable the dynamic channel selection at this location. So going back to the radio configuration on the 5 GHz band where we saw this problem, we can turn on the dynamic channel selection. And once we save it, then we can go back to the event logs that Shriram talked about, right? So here, once we make the change, then the change is pushed back from the cloud to the APs. And then we can go look at the logs which are coming from the AP to see what happened after we make this configuration change. So going to the specific, this AP's logs, we should be able to see what went on. So let's see the logs, and in the logs, you should be able to see the particular event that we are interested in. So you can see here that the DCS handler was triggered on this access point, and the AP changed the channel to a different channel to avoid the interference that was being seen on that channel. And we can also see a little bit more detail as to why this particular channel was selected. So we see basically we expose the details of the scoring logic that was used to make this channel choice. So many of our customers ask us, why the AP is sitting on this channel when there's a different channel available, which in the customer's opinion may be a better choice. So based on the information that we obtain from the AP on which this channel change event happened, we are able to publish this data on the cloud so that customers can see exactly why this particular channel was chosen. So that gives better insight to the customer as to how a particular RM decision is made. And whether this channel selection is driven by a DFS or DCS or ACS, the same information is presented in every case.
Are the thresholds configurable for when it suggests what?
So, for example, if I look at low data rate, right, as a symptom, so the network administrator can configure a threshold for what it considers as a low data rate. For example, a network, can set it at 10 Mbps depending on their design criteria. Somebody else may set it at 100 Mbps for their design criteria. So we are able to take the customer's input as to what a customer means by low data rate. So that in that sense, the answer is yes, the threshold is configurable.
So let me answer it in a different sense. So what we're saying is that you saw the symptoms and the root causes. So we allow you to set thresholds for the symptoms. So the symptom is low data rate, and for that you can set up a threshold because that's what you design your network for. Now, what it translates into the root cause, there are no thresholds on that side. But for all the symptoms that we have, for those you do have thresholds that you can set up. So what do you mean by low data rate? Like Nadeem mentioned, is 100 Mbps low for you? Is 10 Mbps low for you? That's something that you set up. So the thresholds are available for the symptoms.
So in this slide though, so it's showing throughput. Is that so? That's actual client throughput, and are you charting client data rates over time? And is that a chart that I can?
So this is the actual client throughput. In the previous picture, let me go back. So in fact, that chart was captured from Exia. So that is the throughput that we saw on the Exia.
Okay, so that's a chariot chart then.
That's chariot.
Yeah. Okay.
Yeah. On the UI side or on our cloud, they are showing the data rate. The evolution of data rate. So there is a baseline that we capture. How the data rate is evolving. So whatever impact the decision that the administrator made could be seen in the data rate baseline that we show for every client and for every access point. In fact, the nice segue is on the AP side. If you see the baseline for the retry, you could see that at the beginning, the retry rate was extremely high, and after we made the channel change, then the retry has dropped down, to a more reasonable value, which is within the operating baseline of the regular operating baseline of that access point.
Okay, and when you say retry rate there, so this is something I consistently have issues with. Is that the percent of total traffic? Is that percent of transmissions from this client? Is that compared to how many it should have?
This is the retry rate in terms of the frames that the AP is transmitting.
So does that,
the layer 2 frames.
Right.
Does that include all frames? This is does it include beacons and
the data frames.
So it's just data frames. Yeah.
Yes. Yeah.
Okay, but I'm sorry, it doesn't really answer my question. So is that as a percentage of total frames, or is that a percentage of total data frames transmitted, or is it, say, total frames on the net?
No, this is for this particular AP. Let's say it's transmitted 100 frames during this interval between 550 to 530. Within that, how many frames were went through in the first go, and how many frames were had to do at least one retry. So that retry is looking at the frames which were transmitted by this AP. So that's the definition of the retry rate.
Okay, and do you have tooltips kind of explaining where you pull the numbers from? I only say that because point of clarification is very important at troubleshooting.
Right. So what we have is two things. There are tooltips on the UI, and we also have what we call as a Wi-Fi help portal, where sometimes if we have more detailed answer, we can redirect from the UI to the help portal, where are more detailed answers for some of these queries that the admin might have.
Yeah, I think it's a valid point. I see on a lot of dashboards lots of statistics like retry count and channel utilization across lots of products. And for me, all these statistics are pointless and let you know how it's calculated. So retry rate, I could calculate it as a percentage of total packets, a percentage of just data packets, a percentage of, do I count the same packet retransmitted 5 times as 5 retries, or is that just one? So I think it's important to have somewhere in a product an explanation, like a tooltip of saying, what does this statistic actually mean? So I can actually interpret it correctly. If that makes sense.
So that does make sense. So in fact, we have to keep a balance between overcrowding a UI versus providing the desired information. In fact, what I showed earlier, the channel insight, right? So there is an algorithm which is put in the AP. Now we describe the algorithm in great detail in our help portal, and then this insights view is basically telling the customer that how exactly the metrics were calculated as per the formula which was described in the help portal. So that way we are trying to merge the theoretical information which we can as much as we can provide in public domain, and also complement it by the real information for a particular event, what actually the calculation of these metrics look like for that particular use case or particular feature or algorithm that we ran on the So you're right.
If it's available in the help in the help documentation, I'm happy with that. It's just I see a lot of products and they have all these dashboard statistics, and to me they're just pointless because nothing tells me what they mean. So I'm happy provided it's documented.
Yeah, I mean we can absolutely share it, and Jatin can also show what we have there. So let me take a couple of minutes more to go back to where Shri started from, the data platform. So while the RC engine, as you might imagine, needs to look at data from about APs, about clients, about what is going on the wired side, wireless side, applications, and so on. And all this data is streamed back into the cloud, and we have the data platform where we are able to put this data in a form where we can query this easily, build sophisticated queries, and which can be used for different things. A couple of use cases that she's going to talk about. I'll quickly show you interesting, what we are building, what we call as a cloud insights dashboard, where we're looking at data aggregated over customers. So we are anonymizing the data, and we are able to compare the KPIs for customers, and different KPIs could be related to applications, related to RF, related to just the client population. For example, what you see here is, the question that we often get asked, what percentage of Wi-Fi 6 plans are present in the network? So you can see, surprisingly, that there's still a lot of customers who have a significant population of legacy clients, which are, you can say, 11AC and before. Now, the second question is, does the network performance improve if there is a lot more Wi-Fi 6 clients compared to non-Wi-Fi 6? So if you look at, for example, this chart, where we are looking at how the physical layer data rate distribution is with respect to Wi-Fi 6 versus non-Wi-Fi 6. We can clearly see that for non-Wi-Fi 6 clients, there are a lot more clients in the low data rate region compared to the high data rate region, and the situation is reversed in the case of Wi-Fi 6 clients. So by looking at the different data points across customers, we are able to benchmark, and the question was asked earlier, I think, by somebody about the baselines, right? So if we can get this data across multiple customers, and if we find that 90% of the customers have a retry rate of 10%, then I think on balance we can say that 10% is a good sort of number to have as a target when you're looking at retry rate as a baseline or as a deciding factor in the RC engine. So this type of insight can help us build our algorithms better. This also helps us from a testing perspective. If you are looking at, for example, testing a feature, and we want to see what are the clients which are more prevalent among our customer base, then by looking at data across customers, we are able to figure out are there a lot more Apple clients than Android clients, or there are more Windows clients than Android, and so on. So this helps us understand our client profile better, and also we can target our testing and the design more with respect to the data that we see from our customers. And the third point is that, as I said, this can help us improve the RCA, the recommendations, and how we go about doing things on a day-to-day basis for different customers.
Did you say that this data is available for us to look at?
Not yet, no. So today it is for internal use, where we are looking at it and using this to further improve our own offering to our customers. But it is not currently available to third party or
So this is not currently available for users. I think information like this would be very helpful. I see that that's across your customers, so obviously that wouldn't really be necessarily beneficial to a specific end user, but I would like to see that for my own infrastructure, what the number of Wi-Fi 6 versus non-Wi-Fi, oh God, I can't believe I said that. 11AX versus non-AX devices, or the distribution of Android versus Windows versus iOS. That would be helpful to have. And another thing that I had is the demo that you were running, was that a desktop app or was that a browser?
You mean what? The demo?
Yeah, it looked like a desktop app. Was that a desktop application or was that a browser window?
No. So in the demo, that you mean the traffic itself?
Yes.
The traffic was generated through, it was a hyper traffic.
Okay.
I think to clarify, I guess the UI itself is everything is browser based, but I guess to show the impact to the end user, Nadeem was also showing like when the interference was there versus when it went away. He showed the chariot chart for the client. But
so what I'm going to do is I'm going to show a quick demo. So this is the dashboard. This is the UI that all our customers get, right? So when you land here, the first thing you see is a dashboard. So what I'm going to do is, since the last time we did this MFD back in July 2021, we've added a bunch of features, and specifically I want to focus on two things. One is as I walk through a particular scenario, I'm going to call out two things. One is we have really expanded on the amount of data that we have exposed to the customers through the dashboard, right? We'll show all the data. We'll also talk about, your specific question. I haven't forgotten your question about like what happens when, say in high dense, the environment suddenly changes. I'll show you live on like what happens to the baseline. And second is we've also, kind of made changes to the way we expose data to the customers and what customers can do with that data, because the NetDL platform is open. So with that, let's get started. So assume that, let's take a scenario, right? Say you're a network admin and a person called Nishant calls up and says, they have just issues connecting to the network. So the first thing you do is we have a global search. You search for the name. So you can search by like, any attributes, and it shows a bunch of results. I can go click on the client. Now, what you're seeing here is the details of that particular client, okay? Right off the bat, right, even before looking at any metrics, like what Nadeem mentioned, we provide what's happening. We show what is happening with this client, which is, hey, the client is experiencing high data rate, high read rate, and how do I go fix this? So when you click on this, you can see that the way to fix this is go set your channel selection to auto. That's a fix. Now, what I want to do is I want to walk you through the data behind arriving at this decision, right? What is the evidence, right? So as I go look at this client, the first thing you notice is the client chart. We collect all, massive amount of telemetry about the clients, and we try to represent that in a very graphical fashion. Right here, just by a quick view, you can see, the state transitions of the client over the last 12 hours. Now, this is the baseline I talked about. So what I'm going to do is to make it, and these are live clients, by the way. These are running in our environment. So here, what you can see is this particular client was having a good data rate, for a couple of days, and then it suddenly fell off, right? So again, going back to your question of, how do we show this in the UI? Suddenly, if a lot of customers started showing in, and if that impacted the RF environment, it would reflect in the baseline, right? You can see how the baseline kind of falls off. Here, you can see that at some point in time, the client started having poor, data rate, and so the baseline average slowly, gradually goes down, right? Because the baseline is based on weighted average, and the same for RSSI. So what I'm going to do is we are looking at data rate. You can look at RSSI, and you can see that for the last 1 week, exactly at that point, the RSSI actually went down as well. So you can actually start correlating. And same for the retry rate, right? So you can see that as the data rate went down, you can see a gradual increase in the retry rate. So again, this is the data that we provide, that acts as evidence to the root cause and the recommendations. Really quick, the other thing I want to show is the data from the AP. It looks like this client is connected on this AP. So I click on that AP. What you're seeing here is the AP details, right? You move from the client details to the AP details. Again, we show a baseline of all the core KPIs. But one thing I wanted to highlight and show is the RF Explorer, right? Why did we recommend that the AP should go change the channel? So if I go click on the RF Explorer, and this is possible only because we have the multifunction radio, right? If you're doing background scanning, gathering this information is nearly impossible. So because we have the multifunction radio, it scans RF environment, it looks at all the APs with the signal strengths that this access point sees across all the bands. So you see 2.4, I'm going to go to 5 gig because the client was connected to 5. And here you notice that this particular AP is operating on channel 80 megahertz channel from 149 to 161. I think the primary was 157. But that channel is busy, right? You can see right off the bat that that channel has so much of interference from other neighboring APs, and that's why it'd be. I think the environment would be way better off if that AP moved to one of the better channels in the Uni2 band. And now you can start correlating why we made that recommendation to go set the channel selection to auto. If you had set the channel selection to auto, the AP probably would have picked one of the freer channels, right? Again, we have recommendations, but I'm just showing you all the data that goes behind making that recommendation.
So from that view, wouldn't it be better to be able to? I mean, you've selected you're in an AP view, right?
Yep.
Why don't you highlight it with a bright color so that we can see where we are?
Yeah, great question. We have had a lot of customers ask about the color. We are working on it. Hopefully, in the next mobility field day, it'll look better. But we are
because this is, I mean, and my eyesight's not the best, but this all looks the same. So I don't know, and it's very small right now for me.
Yeah.
So, and even staring at that screen all day, I don't know I'd be able to tell, what I'm looking at exactly.
Yeah, definitely. I think,
wow.
Point taken. It's the colors are subtle, right? For example, the gray, I don't know if you noticed, but that is the current operating channel. Hopefully in the next MFD we'll come back and show some changes on the UI. All right. Okay. So I think I'm really sorry. Yes, Peter. Go ahead. Yeah.
Yeah. Obviously, you share this graph that's showed at a particular time. Retry started, data rate dropped off, signal strength disappeared, and you're saying that's because the AP was on a bad channel. What happened at that time for that channel to suddenly become bad? Do you answer that question at all?
Yeah. So yes. So what we could do is we can actually go back and look at the AP. Let me go back look at the AP. This is the AP. So Peter, what I'm going to do is I'm going to go search for that AP. Start, just like Nadeem did. I can go look at the event logs, and at that point in time, we can because we store the history of all that's happened with that AP. Maybe that's probably a time when we saw more clients. We saw the client move to a different RSSI. So if you notice, Peter, at that point in time when the data rate went down, you also saw the RSSI go down, right? So maybe the client actually moved away from its current location. So this actually one of our test devices that is sitting in a desk, and I think it probably moved out to another lab, and that caused the RSSI to go down. But so that's one data point. The second data point is we can go look at the AP logs and see if the AP, did any channel change at that particular point in time, right? So these are the correlations that we can do, and data is all available in the platform.
Yeah, because my thinking was if you're looking at a client suddenly, moves and then their side goes down, there's a number of reasons for why that could be the case. Maybe they've moved to an area with no coverage, and the solution is you need another AP. Maybe there should be roaming, and the client is just not roaming very well. So, there could be a number of reasons for it, couldn't there?
Yeah, totally. I think if we felt, so for example, in your first root cause, which is, hey, you need to add number of APs, if that's one of the recommendation we have in the system already. And if the system detected that the RF environment mandated that recommendation, we would actually provide it. But in this case, it was, it was not the case of the client, having poor coverage. It was able to see multiple APs. So, but it was more about, probably the client moving away a little bit from the access point, connecting at low data rate, and that increasing the, that reducing the data rate as well as increasing the read rate.
Okay, and where do you see these recommendations?
Okay, so the recommendations are right here. So let me go back, go to the dashboard, right? I'll go look at the client because that particular client is impacted, right? So this is the root cause, right? It says high read rate. If I go fix this, it says, set the operating channel to auto. And if the recommendation engine had come up with, say, hey, you got to increase more number of access points, that's what you would see here, right? So today we have, north of 15 recommendations in the platform, and we are, constantly adding it. In this case, it was this recommendation.
So yeah. I mean, for me, I mean, there's a couple of things. Number one, I think the events should be tied to the client. Sure. So there should be a link for you to go, instead of searching for the events log and going to that time, you should be able just to click here and go exactly to the events that were happening there. That's the first thing.
Sure.
The second thing is, I think to the point of what Peter was making is, okay, so you say this client had a high retry rate. Our recommendation is to use auto channel. That doesn't correlate to me because we're looking at one client. I mean, we would need to understand what the environment is like and what the other clients are experiencing as well.
Sure.
So, I mean, for me, if I saw this, I would probably want to know what AP was it, what was it on, what channel was it on, what was the utilization on that channel. I mean, there'd be other things, other factors I'd want to look at other than just one client.
Sure. So let me answer this. Yeah, sorry.
Well, let me tie on this as well, because there's the thing that I'm struggling with is that you're not showing your math, basically. First of all, it says high retry rate due to high contention or low SNR. Which was it? You should know that, and you should tell me which one of those it is. And then, even then, is, what it doesn't tell me is, are you looking at other things that could cause retries, like, non-802.11 interference and whatnot? Yes. And what I see that. So this feels like a pretty generic, like when we see a retry rate, we assume it's one of the following things. But if you know which of the things it is, and it looks like you should have the data to tell me,
absolutely,
recommendations should specifically tell me which of the things it is.
Absolutely. So in this case, if you looked at the chart that I showed earlier, it is because of both the high contention and low SNR. And if it was because of non-Wi-Fi utilization in your case that you said, we would show that it's because of non-Wi-Fi utilization. So all that is, like, if you go back to what the slide that Nadeem shared, which is, hey, what are the symptoms? What are the metrics that we collect about the RF? We correlate the symptom to any of those RF information. In this case, it just happens that it's correlated to SNR or high contention. If it was something else, we would absolutely show it. It's just this environment. And coming back to your question, I just want to be sensitive of the time for Kumar and Jatin. I just want to answer this question, and probably we'll take some of this offline. Okay. So
Shriram, you can actually do something very quickly here.
Yep.
If you go to the performance dashboard, right? Go to the performance dashboard, and click that. Should I look for root causes?
Yeah.
Affected client. Now this is where we will correlate with many clients together, right? So if you just go and click and say yes on that.
Yeah. So let me do it for Pune.
Yeah, yeah.
So
This is now doing things, it's actually looking at the entire location and trying to figure out all the root causes from all the different clients. It's trying to correlate between different clients. If two clients are seeing, retry rate, it will know that this is, a location specific problem rather than a client specific problem.
Okay, so my question is, you talked about the user experience. Why did the user have to call in with this problem? Because the system should have said, this user is having a bad experience.
of course, yes.
And should have failed.
Yep.
So in answer to some of the questions that are being asked here, if we up-level it and do the cognitive thing, I should have realized that my system had a problem before I had users calling in.
Absolutely.
Can you show me how that would affect the dashboard?
So this is exactly what we're doing here. It's already found it. If you can click on that, found 28 clients. So, sorry.
No, you want to?
Okay, you want me to drive?
Yeah,
okay.
good. Sure.
So here what we did was we actually went to that location, Pune. The location that we've chosen is a test location that we have. So there are going to be too many problems here because it's just, we just do all of our testing here. So what this is done here, this is where it goes to the the kind of cognitive nature, right? Where we know that there are 70 clients that are affected here, which are actually showing poor results, right? There are actually 4 clients that are affected at this location. So it's telling you how many clients are affected at what location. You can go into each one of them and it tells you, what is the problem, what is the set of problems that all of these clients are facing, which are the clients that are actually facing this issue. So I could have gone here, or if I kind of go back here, if I look at these 4 clients, it will tell me what's happening here. So we could do this at a location level as well. The example that Sriram showed was when somebody called and said, I have a bad experience. And how do you flow from there? But if you just wanted to look at a location and then do it, I could actually go to like the Mojo networks, the kind of very top location, and I can look at everything that's happening, in my entire network. It will tell me what are the different issues that your entire network is actually facing.
And would I have had an alarm that said,
yes,
absolutely.
Yes, all of this thing.
So all of this can be sent as events and alarms. And see, eventually, I think I agree with you. I think eventually, and that's a vision that Pramod talked about, right? This is how do we build this, self-driving? Ideally, what we want to do is when we identify that, a client is having an issue, and that is systemic, right? Hey, all the clients are having an issue, and we are confident about making that change. In this case, we are really confident because we know that the API is operating on a channel that's highly utilized. We know that the configuration is suboptimal because you actually want to be on auto channel selection and not on a static channel. We can go make that change. Today we don't, but again, that's like the journey that we are on. And when we did that, you wouldn't have to like wait for the customer to call or the user to call. We would make the change and show it on the platform.
So I noticed.
So also to kind of answer this very specific question about that, we should know if it's a retry rate or a high contention issue, right? So here is where it's showing you that if I go here, it says these are the 4 locations which have problem with high retry rate, and this is one location here that's having a problem with high contention. So we are able to differentiate that. It is just that for that one particular client, because we showed a use case where somebody called in and said, I have a problem, and what's my problem? But if I look at it, the kind of cognitive nature of the entire platform, we are able to figure that out and tell you what's happening at which location.